exercise area. Okay. The code name is 08. Okay. No string. Okay. 4 string. So you have a DNA sequence. Okay. Fine. Tata. How will do that? So can you count how many are there? Really? How many are there? TA. How many are there? 5. 1. Then 2. Then 4. 4. So you have 1. Then 4. 1. Then you are doing sliding window. Huh? Or unique? TA, or sliding window? TA, then then TA. Right? So how you will find that? Using the string speed operation. Can you find it?
Instead of that split space, we need to give a status.
Huh?
In that string split, instead of that barcode, we will be giving space. Instead of we need to give like that.
Okay. Anyone? So first, what we have to do? If you have to compute that one, that here are sliding window, what we have to do? Suppose I give a smaller one. Okay, just to test. Okay. So what will be the sliding window outcome for this one? Suppose we do a 4 letter. What will be the sliding window? First one is ATA, T. Then second one TATC. Then ATCA. After that, no. Then only 3 we can make. Correct? Isn't it? So how we can arrive into this one? What is the algorithm that we will write first? So first we need to do something like this. First we have to split it, correct? A, T, A, T, C, then A. Correct? Then second what we will do? Since we have 4 letters to go, so we will start from the first position, correct? 1, 2, 3, 4, 5, 6. So what do we have to do first? What do we have to do? Any guesses? So we need to find out, no? So how many 4 we can make from here? How many 4 we can make? 3 we can do. How we will know that?
Like with how many 4, 1, 2, 3, 4, then 2, 3, 4, 5. Like 1, 2, 4, 2, 2, 5.
So we need a rule, right? We need a rule to end this. So when we will end this? If the length is suppose here 6, correct? And you are moving from first, then second, then third, then fourth. Okay. The moment you reach 4, the difference will be what? Difference will be 2. But if you go from like third to 6, what will be the difference? The difference will be 3. So when there is a difference of 3, then you can execute. If this is less than 3, then you have to stop. Okay? We can put the rule very easily. You have understood that one? So for example, first if I go 1, 2, 3, okay? Then 4. Correct? So 6 minus 1, how much? 5. Okay, let's take the difference 5. Then we here, what will be the 6 minus 2? 4. Then 6 minus 3. Then 2. If you make 2, then the outcome is 4, correct? We cannot make any more. So we have to say whenever there is a 3, that is okay, but less than is there, then you have to stop. Correct? So let's do one more if it's generalized. Let's take one more. So what will be the outcomes here? A, T, A, T, C, A. Then this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So what will be the rule here? So suppose we get what? First, let's take the outcome. Outcome is A, T, then T, A, T, C, then A, T, C, A, then D, C, A, then C, A, then A. So what is the difference for this? 8, correct? Then 7, then 6, 5, 4, 3. So again same rule. Can we use the same rule? Yes or no? If the difference is less than 3, then stop. Correct? Isn't it? So the rule is generalizable. Are you getting this or not?
Yes.
Is it fine? Okay, now how we will write this? This is one that we understood the algorithm. Now I have to write. So what I will do? 4. So first is like we have to split the characters, correct? So what we'll do? We'll do a string split. String split, small DNA split equal to nothing. So this will give me a list, correct? Okay. So since we know that the output for a string split is a list, so we'll first convert this into vector. How to convert? This is my result, correct? So this is my ATM. Okay. So let's keep this as a new. I want to Then what we have to do? Now we have to run from a for loop from 1, 2, 3, 4, 5, 6. Okay, but we want to stop whenever the difference is less than 3. For I in 1 is to length of nu. Correct? Then we can write here also nu minus this, isn't it? Here also we can put the length. Correct? We want to just go to 1, 2, 3, 4. That's it. So we can just find the what we call as the loop that it has to go. For example, I say the diff length of nu minus how many? 3 or 2? If we do 2, what will be the result? This is 4. Okay. So the fourth element is 1, 2, 3, 4. Okay. So we want to give it 3 because we want to run till the diff only. For example, 1, 2, 3. That's it. Till then only our 4 TATA will come. Correct? So now the diff 1 is to diff nu. Then what? I. Then I is to from I to what? How many elements? 4. So it will be what? I plus 3. So of course I is equal to 1. Is it fine? The result? ATT. What we have to do? We have to do a paste again. Because this is a vector, so what we'll do? Collapse. Okay, are we getting our desired output? Yes. Correct. Then next is TATC. Okay, we'll check that one again. I is equal to 2. Is it the same? TATC? TATC is fine. Then I is equal to 3. ATCA. Is it the same? Same, correct? So now the diff is what? 3. So we will get only this much only. And the output we will store in, let's suppose we say KMR 4. Correct? Is stored in the list, in the vector. Now what is our objective? After this we have to find where there is a TAT, correct? Equal to TAT. Anything is there? No. Okay. So now this can become our one of the what is your functions. So we say KMR 4 equal to TAT. Okay. So now we just replace with our small DNA with what? The DNA. You see whether it works or not. Nuke is this. The diff is this. 22 times it will go. Then MR. How many were there? TATA? How many were there? 1, 2, 3, 4. That's it. Which correct? The result is how many? 4. Okay. Now the best thing is whether you have understood what the problem is. You guys how we solve the problem? So first thing that whenever you get this kind of very difficult problem, it might be very wrong. The first thing is make it a very small portion of an example set for yourself so that you understand it. Okay. Then after that, what we did, we designed a steps. What is the step? First, before we have to get there, what we have to do first, split the whole string. Correct? Then the second thing is how you will devise so that you only get four what do you call as letters only. Then we designed the algorithm that till when the for loop will reach there, we have to stop because after we reach in the third position or the second position, it is pointless. If you actually bind them, then we will not able to find the motifs or the TATA, whatever our main objective is. Okay. So now what you have to do, if you have understood this problem statement, you are going to do one more little bit similar this kind of what you call it, exercise. But before that, have you understood the problem? The approach. Is it clear? Is it clear or no? How many know? Where you have doubts? Yes. Where you have doubts?
How to extract DNA from the small DNA?
From the small DNA?
Yeah, from DNA, how to extract that small DNA?
Okay. So this is the small DNA, correct?
Yes, small DNA.
From here, what you have to do?
No, from the whole DNA.
Okay, whole DNA.
Yes, how it comes the small DNA.
Okay. So this was a small example. Okay, this is a 4-letter motif. So the objective, the question was, if you have a DNA string of like this, very long, okay, can you find TATA? Okay, so by just manually hovering, we got okay, there is one TATA, correct? Then second we can have here. Then after that we can have here. Then we can have one more. After this, can we get any TATA? No. So what we have to do first, before we find this, first we have to split this whole string into what? 4-letter codes. Correct? How you will do that? So that is the problem. How are you going to find 4-letter codes from a string? To do that, we first have to create single letters. Correct? That we can do with what? String split. Correct? Which we have learned. Then to get 4-letter, what we need? The rule is that you have to go from first till fourth. Then you have to go second is like 2 to 5th. Then third position to 6th. Then after that, do you require to go again? If you go also, then you cannot create 4-letter. So you have to stop your for loop. So the for loop will go from first, second, third. And to find the third element, what we actually discussed that total length minus 3. That is the number of loops that we have to go. Okay? Is it fine?
Yes.
Is it fine? Okay, then what we use? Then we use the paste operation to whatever the nucleotide that we got. Okay, so let me write it very well so that you get the understanding. So first operation was split, right? Split into letters. Then this is find number of loops. Number of loops that we have to write. Then this is empty. The vector which will contain our information. And here what we did? So for every nucleotide we find the k-mark. Okay. And this is k-mark letters. Then we join this. This is fine. Which one? So this is just to remember. You can put k-mark also. That is not a problem. I am just doing for just so that I remember there is a 4-letter we are doing. That's why I am just giving that 4. K-mark 4. Just for remembering. Suppose I run the small.
There are four I in one column gives you that line.
Okay. So the nuke is ATATTCA, right? Then what we did? Then this is the diff, means number of length that we have to go. There is 3. So length of nuke was total 8 or 6. 6 were there, right? Then second is we made an empty vector. It does not have anything. Okay. Then so 1 is to diff means it will run from 1 to 3rd. That's it. Okay. It will not go beyond that. So for example, let's suppose I is equal to 1. We do. Then what we get? So nuke I is to I plus 1 means what? From first position to fourth position you have to go. Okay. And you will take out the information from there. That is like AT. Is it fine? Then you take out that information for k is equal to 1. AT. Then what we did? We did the paste operation because k bar letters is in vector, so it is collapsing. And this is storing in the k bar. So this is the first round. I is equal to 1. Now we do I is equal to 2. Okay, again repeat k bar letters. So we will get the next 4 letters. Okay. Then we do the paste, we will get the TATC. Correct? And we will store that into the KMR 4. Now KMR contains the first and the second. Then I is equal to 3. Same thing. So this is the full row. So total what we are getting, the total number of KMRs is 3 from the small DNA. Is it fine or not? Is it clear? Is it clear? Any doubts? Doubts, please.
What is KMR?
Huh?
What is KMR?
Which one? This one or this one?
Over.
This one. This is an empty vector. You are asking what is KMR?
Yes.
Okay. So anything we say dinucleotide, for example, there is 2 KMR. 2 KMR is nothing to do with, we call it a dinucleotide. Okay. Dinucleotide, you understand? For example, we have a sequence of A, T, G, C. Then what will be the dinucleotide for this one? AT, then TG, then that's it, correct? So these are our dinucleotide, which we call as a K-mers. K means that you can say there is a tumor. Okay, one of the names that you can give is a tumor. Then 3-mer, 4-mer. Then you have pentamer. Those are like 5 nucleotide together. Okay, so we in general we call them as a K-mer. Is it fine? Okay. Anything? Anyone?
Sir, can you explain in
Line 25. Okay, what we are doing here? Okay. So let's take our small again so that it becomes easy for us. So if you look carefully, so this operation is very important. Why? Because for every loop, you have to say that you have to go from the first to the fourth element. Correct? So the first element is already there, 1. Then how many steps we have to make from there? This is 1. Then how many steps? 1, 2, 3. That's why plus 3.
I is 1 and plus 0.
Plus 3. So it will go to 4. For example, for second position, if my I is 2, then how many steps I have to go? 2. That is fine. Then 1, 2, 3. Getting? So that's why always plus 3. That will get me to the fourth position from the corresponding position itself. Is it clear?
Yes.
Okay. Then for example, I is equal to 3 if it happens. Then 1, 2, 3. Correct? Is it fine? Is it fine? Yes, yes. So I is yes.
For every lengthy sequence,
Hmm.
you have to give for every lengthy. Like 1, 2, 3, 4.
Yeah, so that's why we computed that one. Na? For example, for long sequences, we find the rule that the total number of nucleotide minus 3 is the way to capture the 4 mark. But suppose you have a 2 mark, then the rules will be different.
Okay, if I have 3 minus, again we will be different.
Exactly.
We have to change it according to.
Yes. So that's the next exercise that we are going to do. You are going to tell me the rule for 6 mark. Okay. I am just giving you this small sequence and tell me. This is as a reference I am giving. Okay. This is one reference so that you can find the rules. Now, what will be the rule for this? Anyone try? The same way you can just use. Use the small what we call as the same rule. How we have come up with this one for this one 6 months. So outcome that we expect. So the input will have A T A T C A T T T. Let's suppose we use this one. Okay. The desired outcome is A T A T C A. Correct? Then next P A T C A A. Then A T C A. Then C A. Then A T. Okay, D C A. Okay. Then C A T. One more A. Yes. Then A T. Then that's it. Na? So now what will be the rule? Can you define the rule here? Yes. You try. You try. Try the rule. You can type in your while he is doing in this one. The first position, just write the position as we did for the small DNA. Yeah. Put right there. Yeah, here it is there. You have to see it. So for example, 1, 2, 3, 4, 5, 6, we write wrote the this is the position. You can write up the position. Hash, shift hash. Yeah. For A, this is the first one. No, space here. Next space 2. Then 4. Then 4, 5. All the positions. Just get the positions. Then 6, 9, 5, 7. Me. So.
It's fine. 6 months.
Wait. But And
To whom?
from there. Correct.
Everyone is doing.
Give to Alex. I'll wait here. You want
What is
Yeah.
this?
No minus.
Google. Okay. So you found the rule. Very good. 10, 9.
And 9. 8, 5.
5 would come.
5 will be there or 5
No,
will
no.
come?
No, 5 won't come.
But
It's 1.
5.
So 1, 2, 3, 4, 5, 6. Correct? Then after that 1, 2, 3, 4, 5, 6. Correct? Then 4 or 3? 3, 4, 5, 6, 7. No, 7, 8, 9. No, we have 6, correct? Here. So the rule is different. Okay, let's now give this is secondary. So first is you will get the value from 1 base till here. This is the first value, correct? So this is our first. Then let's suppose we do second. It will start from here and it will end here. Correct? Then next,
8.
third. Then
9.
4. Then
10 is 5.
Marking position. 6, 6, 6.
then
Then 6.
then 6. Okay? So now after this you cannot make anything. Correct? So what is the rule? It will be 11 minus 5.
6, 11 minus 6.
5 is 6. Correct? So if you just look very carefully, the rule is very simple. Length minus the camera length. What is the camera length? 6. Then plus 1.
Uh-huh.
No problem. So 11 minus the camera length, which is what? 6. Then we are saying plus plus 1. So how much it will be? It will be 6. Correct? So it is saying that you have to go from first position to the 6. Is it fine? Is it fine?
Yes.
Is it fine? Is it fine?
Yes.
Okay, again think over. Again look it very carefully. The first loop will go from 1 to 6, correct? The second loop will go from 2 to 7. Then third loop will go from 3 to 8. Then the fourth loop will go from 4 to 9. Then fifth will go from
5 to 10.
5 to 10. Then 6 will go to from
6 to 11.
6 to 11. Then after that, no.
End.
Okay, perfect. Now can you write it? Simple, na? Now you got the information of number of diff also. Diff is what? 6. So 1 is to 6. Okay, so what are the things that you find out from here? So nucleotide you can find out, correct? First, then the diff. Diff is how many?
Length.
It is 6. Then you will put KMR 6, correct here? Because it's a 6 you are finding. and you have to just run this. And most importantly, what you have to type here? What will be the rule here? I is to I plus huh? 5. Why 5? Very good. Okay, now write. So this is the rule is fine. Now write. You copy this. Just understand first and write. Okay. So this is the sequence. Control it. So if I do the this one, control enter, then what is the this here? The formula. This is 6, right? Then plus
1.
then this is KMR 6. This is there KMR 6. And here
5.
5. This type KMR 6. Mark in here 6. Enter. Is it correct? Is it correct?
So here we're giving 6 camera length is 6 and plus 1 is each one is 1.
Where?
So this one.
Here.
Yeah. This number is 1.
So this one is for so that to make up the position. Correct. If I do so, this is the KMR what we call as the length that we desire. Okay, that what we want. And just to so that we always get the last element. We are saying ki plus 1 is to be included because if I say length of the nucleus minus 6, then it is going to give me one less KMR. So plus 1 for so that we can cover the total KMR that can be generated from the sequence. Fine. Okay, now type. First write this one. Go to your sheet. Okay, start from the small DNA. Start from the small DNA. Yes. Yeah. Scroll down. This side. You are doing for the small one only, na? Yeah. You have to write something else. 4 plus 1. This is same thing like 3 like 4. So 6 is for the number of chambers. That was 6 1. This is 4 1. Na? So we have to write here what? Okay, so 3 will be 4 plus minus 2 plus 1. No, 3 that time because we chose here. Na? This is the rule we have. Like the third position only we have to do. That's why. 6 minus 3 is equal to 1. The same thing you have to do. This is what implies minus 4 plus 1. This side minus 4 plus 1. 4 is the k1 and plus 1 to and means the last one. Minus 4 plus 1 is minus 3 only. So why we are worried so much about this thing? Why we are so much interested in string split and why we are learning this KMR and all those stuff? Any idea? Loud.
In genomics data, the particular nucleotide sequence or the
Portion it?
we need.
Okay, anyone? Dinata, why we are learning this? Dinata, any
Yes,
idea?
sir. Like to identify the if your gene of interest something is the land is there, so we can identify our gene of interest from the whole genome.
Okay. Who have done microbiome here?
We all of that.
Huh? How you find OTU? You have attended the class of microbiome, na? Operational taxonomical unit. How you find that?
Clustering.
How you find that? Okay, how the data looks like? Once you do the experiment, you do a sequencing. How the data looks like? Reads. What is the size of the read? What is the size of the read? 200 nucleotides. Then what do you do? After you get your sequencing done, then quality check. Then what you do? What?
Demultiplexing sequences.
Demultiplexing. When?
After QC.
Define our data.
We do demultiplexing. There is
Under
demultiplexing.
demultiplexing.
Okay, where is the slides you have? Do you have the slide? Which one?
Commander. What
Okay, can anyone explain this one? What we are doing here?
So first we are importing sequences from our directory to the kind2 by using this format cassava 8 that we are using that format. We are importing sequence to the kind2.
Then
We are merging because we have parent sequences, so we are demultiplexing that part, the single sequence.
then
And then we're doing denoising, trimming, whatever, like after QC, we can fix our values and all, so we can do trimming and all. This is in denoising, we're doing that.
Trimming.
Yeah.
Then
And then we're generating the feature table by giving our information.
okay, then
Yeah, this one actually, we about this one by using the that classifier file. So here we are using Binging database.
okay, what is green name?
It's a factorial database where information reference database.
Okay. So how we are assigning that one after that?
Yeah, so we have our now the representative sequence, and then we are aligning with our green gene database reference gene.
Okay, how we are doing that? How we are doing that?
So here the mainly we are using the cluster. We are forming based on the sequence uniqueness where the cluster is formed. According to that, queues are like formed, giving the different queues, the uniqueness of the sequences.
Anyone want to explain this? What is a pre-trained knife-based classifier?
From the whole 16S RNA, so we have trained for V3 and V4 regions. So we are taking out those regions and then we are aligning.
What is pre-trained knife-based classifier? What is this? Or what is naive-based classifier? Anyone? Anyone? Anyone have any understanding about this? What is this? Have you learned about machine learning? Machine learning?
That's our land, but
Can't remember. Okay, naive based. What do you mean by classifier anyway? Let's forget about naive. Do you know what is classifier? Any idea?
Classifier is like classifying things according to their like rotten apple, good apple, bad apple.
Okay, very good. Then regression. What is the regression then? Regression? Okay. So, can you classify human being or gender, male or female, based on their hair length?
No.
Is it a no or yes?
No.
Inside this room, can you classify the male and female with the hair length?
Yes.
Very good. So now, just think about it. If I say male and female, okay, that becomes what classifier? Okay. Suppose you want to predict the hair length. Okay, hair length will be in centimeter, correct? Or millimeter? Okay. Centimeter, let's suppose we keep it. So that's a numerical value, correct? So that becomes our regression problem. So that is the difference between a classifier and a regression. Is it fine? Age is a what variable?
Numerical.
Numerical and continuous. Can we treat that as a regression problem or a classifier problem? What will be that?
Sir, not yet able to understand the difference between classifier.
Very good. So classify means anything to it categorical data. Okay, like for example, you want to classify blue pen and a red pen. Okay, that is a classifier.
Okay.
Suppose you want to find the color gradient. Okay, that becomes your continuous scale, correct? From 0 to 255.
Yes, yes.
Then you call it as a regression. Is it clear?
Yes, sir.
Is it clear? Okay, now I am asking whether age is a we can treat as a regression problem or a classification problem? Age?
You can segregate with the 8 and 10 to get something like that. You can classify.
I am asking age. I am not asking the age group, correct? Yes, age is a regression or a classification we can take.
Regression.
Regression, very good. And if I ask the same question, then what we told, like age group, for example, I can classifier, very good. Okay, you have learned microbiome, but you did not learn this one, huh? Very nice. Okay, what is green gene? Huh? It's a database, everybody knows about it. But why it is name called as green genes? Why not orange genes, red genes? Why only green genes? Nivanga, you are the expert. Tell.
No, sir, I'm not expert.
Why you did not ask the question then? Why is green gene? You should have some meaning, huh? What is the full form of coin?
Quantitative insight into
Microbial ecology.
Why it is 2?
people updated. Time was updated time too.
When are it updated? What's the problem in coin 1? What was the problem in coin 1? Okay, no problem. I'll give you what you call as freedom. So what is sklearn anyway? You have used this command, na? What is sklearn? Classify sklearn. How many of you uses Python before this? You use Python. Do you know what is sklearn? Library, yes, correct. Then
Classify the data.
what prepare?
Classify the data.
To classify data is sklearn module. Okay. Then okay, sklearn is there. Like for example, in R you have packages, correct? So in Python also you have scikit-learn. Okay, scientific kit for learning. Learning means machine learning. Okay, there is sklearn what is given. So Quine is actually using Python module and it is using the model that is built which is stored in this particular artifact, and now it is using that one to classify the groups which is there for you. But what it is taking inside? Do you know what is taking? Yeah, do you know what is taking inside so that it is able to classify?
That's fine.
So green gene database contains what? The sequence that has been trained only including 250 bases from the V4 hyper variable region. You understand V4, V1 and V3, na? Variable regions, do you understand those? Seriously? Or okay? Okay. 16S everybody knows, correct? Now it is pre-clustered into 90% sequence identity. What do you mean by this? Clustered 99% sequence identity. Anyone want to explain about this?
If there is 1% difference in the signal, then also they will make it a different cluster.
Very good. So clustering is done based on the 99% of similarity. How it is done? Based on the nucleotide. So what is trying to do now? You have a database where you have a basis, okay, for V4 region, the nucleotide, 250 base pairs. Now you are doing sequence mapping and doing clustering, and it belongs to specific clusters. What you have got from your experiment? From your experiment, you also got bases, nucleotide bases from this particular region, correct? Now you want to do very quickly, where already they have built a model for each of the specific taxonomical group. Suppose this is my what you call as green gene. Okay. If I go with my teacher, what do you know, color of my shirt, I will map to whom? Red color. Correct. Because most nearest. So it will take huge amount of time for me to go each and every one. But if I have a model already built in where the color is already organized, for example, he will be there and she will be there and you will be there in one cluster, which is more closer based on the color. Let's suppose we call it as a 99% cluster. So now in the supervised what you call classifier, what it is doing, it is trying to predict my color of my shirt, and it will give it me directly into that group. I don't have to go each individual person. Okay, so the difference between this model is what? That we are doing a machine learning which is supervised. What? It is a supervised machine learning. And if I don't do, but I go individually one by one, then it is unsupervised. So likewise, this is more like a supervised version. We have to do a unsupervised version in our problem statement. Okay, where we are asking this particular pattern, find me from that sequence one after another. Okay, so what we will do after the T, we will find out TA for big sequences also. Okay, what is that? This is a unsupervised methodology where first you have the input, then after that you create k-mers, then you map the k-mers, your specific k-mers which of your interest, to the older chunk of the k-mers from your input sequence. That's it. Okay, if we have already k-mer index, then we can also directly go into, then ask the question that can I place my k-mer to a specific bean. That's a more of like a supervised one. For example, you will have motifs, different motifs, correct? For different motifs, you will have different sequences. Motif identification you have done previously in your MSc, BSc. What it says that you will have a specific pattern, and that will be present across the different species. So how you find that? It is because there will be some mismatch also will be there, or there will be some signatures will be there which is very specific. Okay. Chalo, let's go for a tea and let's come back and solve this problem again. Is it fine? Meanwhile, just keep thinking about the algorithm again and again. Okay. Chalo. Have you understood? Less. Or fully understood? What? What? Did you learn this?
बीच में फोर्थ के बीच में
No, let him try. No, let him try. Because he was having doubts with data frame. So I asked whether he can create a data frame first before he asked the doubt for data frame. You sit, na?
आराम से करना
This is a spread of sequencing is from 1 to 11 is, and here we want to see from where we start is the 61 is 11 minus 5 equal 1, which is first we start with the 11 the 6. This is the first point. This is the second point, 11 minus, and this is the third point, and this fourth point. The fifth point, it should be the 10, and this is the sixth point, the 11. And this is here the possibility of our sequencing, as in whole sequencing. First, we have A, T, A, C, C, A. And the second will start from the T, A, T, C, A, A. And this like so on like this. This is the length of our sequence if 11 minus 6 plus 1. We included the 1 because the plus 1 because we want to say to, if we didn't include 1, it should be like a minus 1, it should be in the minus side. And we included the 1 as we included all our sequences here. And then this is our new sequencing is we want to use this function to split our sequencing. Our sequence. This is a split sequence. This is a command or the function. The paired frames, and here we splitting into the letters, different lengths. This is our sequence.
Yes.
Yeah. And here we use this Kramer 6. We use the Kramer 6 because our length of sequencing is the 6. Yeah, we use it here, the Kramer 6. And then we can use the Kramer 5 if our length is 5. There's no need just for depending on our sequencing. The length of sequencing, Kramer 6, is including this open sequence of vector of code. So this is our OR. Kramer minus delta equals new. The length of the sequencing equal in I5 equal the I equal 1, and then 1 plus 5 equal 6. This is our length of the sequence.
Kusumi, you have a board or something? Or we can use the phone? No, board you have to go up. Okay. There's no board which we can use.
Will you go upset?
No.
Okay, I was born in a book.
Take out. Marker is the
That's still.
Is a canvas one, no?
this is canvas, Baba.
This is a drawing.
I'm not a board.
So here you want to show the thing, is it?
Yeah, no, I want to just illustrate so that they understand better. Otherwise, they will be in here.
We go to the classroom, sir.
Huh? But they need to understand here also. This also we need. Both the thing we need.
What do you mean?
Yeah, so what we can do?
Yeah, this is here. Our target we ask if it's not there. It's coming 0 because it's not there in our.
Yes, perfect. Okay. So anyone want to try again? Anyone? Okay, I'll randomly now sample. If nobody says, I will randomly sample. How many students we have today? Anyone count? Okay, number 2, 3, 14. Number 2, 3, 14. Who is 2?
Where I started.
Number 2, you, huh?
Yeah.
Yes, come. Number 3. Number 3. This number 3 just tell him, huh?
Yeah.
And 14. Who is 14? 14. Number 14.
Sweetie.
Huh?
Sweetie.
Waiting. Yes. 3 of you decide who will go and explain. You explain with a small one. Okay. So what is the problem that we are asking? First tell. What is the problem that we are asking?
We are trying to find out the four that KMR
Uh-huh.
that the small nucleotide sequence.
Uh-huh.
So the patients find this TA sequence.
From the input sequence. Yes. 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 No. Okay. Then.
And for finding that that small portion from that sequence, we have to separate each of these characters.
Uh-huh.
So for understanding we can separate like this as an individual,
Uh-huh.
and we can mark the position of that character.
Uh-huh.
Then after that, to reach this like this is four mark. So 4 mark, we already decided this is 4 mark. Depending on the patient.
Yes.
It is 3, 6 like that. So it is 4 mark. So
We have to do what? Sliding window.
sliding window.
Okay, if we have this one, then this, then what will be the sliding window for this? This is first one.
Yeah.
Correct. The next one will be
One will be shift. Position will be shift.
correct. Then
ATCA. Then TCAA. Then CAAA. And then double.
correct. So this is the what we need the outcome. Correct. So this is our sliding window of this input. Everybody is looking at the screen, na? Huh? Everybody is looking at the screen.
Yes.
So this is our sliding window that which we desire, correct? From this input. So to do this, what are the things that we have to know? The first thing is that we need to know when to stop. Correct. So for that, what we devise that if you have 9, then and you have 4 mark, then what we have to do? N minus the A mark plus 1. So what will be the answer for this one? N minus 4 plus 1. Result?
9 minus 9 plus 6.
Huh? What is the result?
9 minus 5 minus 4 minus 9.
What is the result?
6.
Very good. So we will move from the first position 1, 2, 3, 4, 5, 6. Till there only we will move. Correct. To move that one, first what we have to do? We have to do string split so that we know we will get all the individual nucleotides. So for this also similarly, what will be our sliding window? First is A, T, A, T. Next, T, A, T, A, T, T. Next, A, T, C, A. Anything else? No. Why?
Because we want
T is the
4.
last.
What is the length of the sequence here? Length of the characters?
6.
Minus 4.
4 plus
Plus
1.
1.
Answer? 3. So what you are doing here? First, string is placed. So we are getting all the nucleotides A, T, A, C, A. Okay. Then we are getting how many loops? So because we already know the length of the nucleotide is 6, which we are capturing here. Correct? And the K bar is 4, then plus 1. So this is the number of loops that we have to run. Correct? So now K bar is an empty vector. Then we are running the for loop. Where if I say I is equal to 1, then what we are capturing from here?
1 plus
1 to 4. And from the vector nucleotide. Are you able to understand this? Everybody is clear? Everybody is clear with this? Anyone who is not getting this point? Anyone? Anyone? Everybody is clear with this?
Yes, sir.
Okay. Now we are storing this in output into K letters.
Again, there were doing I plus 3.
Yes.
Again, again came up 4.
you are giving that command?
Because we want to explore this. So now KMR does not have anything. Okay. Now in the ith value we are storing. So ith value is 1. So KMR is a vector. The first element is AT because we pasted here.
What is the meaning of this? Here I understood.
Ah.
Is equal to 1.
Yes.
So 1 plus 3, 4.
Yes.
But here, what is the meaning here? 4.
Okay, here 4 we are saying because we are just keeping that this is a 4 mark. 4 mark. If we type here XYZ, that is also fine.
Okay.
For example, if I do XYZ, and I have to just do here XYZ. So why we are doing the variable name? This is human readable. So if I don't type that, someone will come and then they will not understand what is XYZ. So for that we are just keeping in the name only KMR 4. So that somebody will come, they will okay, this is KMR of length 4. That is self-explanatory. So we run this, so we get our desired sliding window KMR. Is it fine? Is it fine? Okay. If this is fine, now without looking the code, can anybody write? Huh?
Lens it.
Huh? Can you write? Yeah, I will give you the problem again. Okay, this is one. You have to do a KMR of this. This is the input 5. Input equal to this. KMR is equal to, let's suppose, 5. Can you do the sliding window now? Yes. Okay, just write the sliding windows for this. Only sliding window. You write. Oh. Question. You will get your question.
No, sir. I was trying.
Everyone is to come here now. This is done. Very good. Okay, come out. Okay. So this is the desired output that we need. Okay. Now, second. So, what is the loop? Number of loops that we will run? So, can you do the string split? String split? Yes. See the string split. String split of the input. Okay, you don't remember the what you call it the command. So string split is what? String split is a function. So for that you need the parenthesis. Then after that we did square bracket 1. You remember this? So if you do this, then you get the information. But here we have to run first the input. Control enter. Okay. So this is your splitted one. Correct? Now can you write the how many loops that we will learn? Yeah. Dave. What was that? The rule. Rule was length of the length of the input. What is the length of the input? This is this one. How many are there? And what was the desired output? We wanted 5 plus 1. Okay. Then run the for loop now. Try a for loop. What was that? First you have to define an empty. Empty chamber, yeah. Chamber 5. Very good. Now the for loop. For loop. For anyway, this is a function, no? So for parenthesis. I in 1:5 div 1:5 div. Then curly braces start outside, come outside, enter. Later, yes, equal to what was that? How to get the sliding window now? Input. There is a let's see, huh? Yeah, let's see type. Let's see square bracket. Where square bracket? Square bracket. Square. Yes. I is to in bracket I plus 4 because you need 5, correct? Then next enter. No. Enter. You have to now store into chamber 5 equal to taste of. Yeah, that is chambers. This one chamber letters. Comma. Collapse. Yes. So now what is the here you have to type the I. Square bracket I. Chamber 5. Then square bracket I. Now run from the beginning. Control enter. Very good. Now check chamber 5. Enter. Get the same result. Very good. Okay. Now we will do again random sampling. So now we will not take what? Huh? 2. You forgot your roll number. 2, 3, 14. 2, 3, 14. Okay. 1, 18, 7. Come. 1, 18, 7. 1, 18, 7. Everybody will get chance. No problem. Okay. 1, 18, 7. Your problem is very simple. Cat, dog, human. So you have to first 3 months you have to find. Okay? 3 months. Okay, first take the 6. Take your position. Write the sliding window 3 months. Cat. Please. Type cat. Then next. No. 18. Yes. Then.
Is it like rescuing?
Start. Everyone. Where is the other one? 1, 18 and one more was there, no? 7. Where is who's 7? Smart. Okay, done. Very good. Now you sit. You do string split for the input, right? It's calculated. String split of the input. String split in quotes, right? Cat, dog, human. In quotes. Yeah, quotes. Yeah. Yeah, right. Cat. Give it. Cat, dog,
Understood the concept, right?
human. Comma, split. So this is coming in list. So now come make it to vector. You remember the square bracket? At the end you have to put double square bracket. Go back. Here in the end. Double square bracket. 1. Enter. Okay, store this in a variable. Just name a variable, random variable. Yeah, you can do any. You have to assign the variable. Yeah. Anything. Yeah, GG also fine. Yeah, GL. Okay. Very good. Control enter. Now you contain all the letters there. Correct? Now find the length. Length of B is here. Length of GF. Hey, parenthesis only correct. Parenthesis you need to put. Parenthesis. Function, na? Yeah. Minus what? How many gamers here? 3, na? So you have to put 3. 3 plus 1. Plus 1. Calculator. So you will do 9 loops. Correct? So just type diff equal to this. No, diff equal to this. Hi, Bixu boy. Hello, how are you? I am good. Can I call you in like half an hour? Very good. Then for loop. Boy, you come. For loop. Let me try and run for loop. Don't see. Exam is going to be over. That's it. You help us. Sit. Tell me. What? Everyone practice before your turns come. Right, good. Perfect. One is to what div there is, not I plus 3. One is to div. One is to div it is. Plus 3 is not required. Plus 3 is not required. Div is required. Then if curly braces come inside for loop. No, outside. Enter. Yes, now letters. GL square bracket, I square bracket, square bracket. GF square bracket, I is to I plus 2. The remaining bracket. Square bracket I, square bracket. Okay. The base of base parenthesis K under KMR underscore letter comma collapse KMR letters comma collapse collapse.
From starting.
Right? From 07. Come down. Come. Yeah. 07. Check. Check your value whether it is desired. Control 2. KMR 3. Enter. What happens? It is not coming. You forgot to put in the GF I is 2 in bracket I plus 2. Parenthesis in bracket I plus 2 should be in bracket. Okay, now go there from the 100 number 5. Line number 5, 105, start here. Run. More. Now check. Control 2. Schema 3. E. Enter. Is it fine? These are the mistakes, huh? Small mistake, different results. Okay? You have to be very careful. Okay, now what was your roll numbers? 1, 7, and yours? 18. 18.
I'm 17.
Okay, so what is gone? 1 is gone, 17 is gone, and 7 is gone. 9, 16, 12. Who is 9, 16, 12? 9? You're 9?
Yes.
She is 7. Then 8, then 9. 9, come. Then 12 and 16.
I'm 17.
Yes, come. Come. Okay, your problem is very simple. You will get very easy problem. The problem is you have to find out reverse schemer. Okay, what is reverse schemer? Suppose you have an input A, T, G, C, and you have to find suppose schemer, but this is reverse schemer. Okay, what are the schemers for ATGC? Go to what?
TGGC.
And reverse?
GBTA.
Are you able to do this? Who are there? You and you. You want to try that? Okay, so what we will do? Split into A, T, G, C. Then second what we will do? We have to reverse. Reverse how we will do? There are many way of doing it, but let's say we do reverse. C, G, T, A. Then this we will find out. Means how many loops we have to go. So how many loops we will go? 4 minus 2 plus 1. So how many? Equal to 3. Very good. Then fourth what we will do? We will find 1 is to
1 plus
I plus 1. Because 2 only 1, correct? Dinucleotide, so the rule will be different. Then the fifth, we will do join with paste. Simple? Okay, now right. First do string split. Who want to do string split? You? It is very easy. You go. So first write the input equal to, input just write. So there is input equal to ATGC. Imports ATGC. Course. ATGC. Okay? Done? Now string split this one. Yes.
On the hash.
Okay, so it is done. Okay, now you assign this into something variable. Suppose v1. Go up, assign it to v1. Assign me. This is not assigned right now. It's told v1. Yes. Assign. Equal to. Control enter. So you will first run this one. Input. First you have to run the input. Input. First you have to run the input. Then come down in a second. Very good. Okay, now you will do the reverse. Reverse the v1 using the reverse function. REV. Control Z. Control Z. One more. Come down. Yeah. Rate of v1. This is a function. v1. Capital V1. Okay. Control enter. You got the reverse. Now assign the RV1. Go up. Assign that particular function. 109, line number 109. Go. Store that information. Store this information in a variable. So here only you will type RV equal to control enter. Okay. Now come down, control to RV. So you have the reverse date. Correct. Now find the date. Go to the code. Date equal to length of by input, which is RV. Then minus number of nucleotides. How many we learn? A1 is 2, na? So it is 2. 2 plus 1. Control enter. Now you find the date. Now you create an empty what we call as schemer for 2. Schemer 2. Very good. Now you write the formula. Yeah. So whenever you guys are facing one problem, so whenever you are typing in your own system, you have a reference point and you are looking. So that's why you are feeling difficulty in here, because you have to now only focus on the current problem. Correct? So very important to practice. This is 4 in 1 is to diff. 1 is to diff. Y I in. It's fine. I in space 1 is to diff. 1. First 1 from the loop number 1 to diff. Yes. Now come down. KMR letters. KMR letter this is first. KMR 2 is already letter. First you have to extract the letters. RV square bracket 1 is to where 1 is what? I is to no. I is to, then inside that I is to plus 1. I plus 1. I plus 1. Yes. Now come to your KMR 2. You have to do the operation for paste. So what is missing here? Anybody?
I.
Huh?
Bracket I.
KMR 2 bracket I. KMR 2 square bracket I. Now run from the diff. Run from the diff. Diff. They start here. Enter control enter again. Control enter and one more. Control enter. Yes. Now check your results. Control 2. Keyword 2. Very good. The more you will practice, more you will remember. Okay. What was the roll number you guys had?
60.
What was the roll number? 9.
16.
And
What's yours?
My roll number was 12, I think. 12.
11, 13, 5. Please come. 11, 13, 5. Don't be afraid. Keep smiling. Okay, you will have more tough problem or a easy problem you want?
Tough. Very tough.
Tough.
Yes.
Why?
They are genius.
Okay, so what is the objective you have to find? 9 marks. Okay, find the 9 marks from the output, also from the inputs above. Okay, please, whoever who want to sit first. Okay, the string is split. First is string is split. Assign to a variable first. Assign to a variable first. Yes.
Yeah.
Copy paste. Copy from there. Control enter. Control enter do first. One has to wait. Yes. Now you do string split. String split of hello. X equal to very good. Control enter. Very good. Okay. Now find the diff. What will be the diff? Very good. Control enter. So what's the issue? The problem? Yes, X is capital. Very good. Yes. Now second person come. Come second person. Yes. Run the for loop. First create the empty variable name MR9. Gamer 9. Very good. For I in. Very good. Inside tablet bracket, first letters, name or letters. X. Very good. Very good. Now run from the beginning. From the X, you can start from the X. Control enter here. Very good. Now check the output. It's okay. From there also you can run. Control enter. Is it fine? Very good. So now you have to convert this into function. Is it fine? Okay, right. Convert this into function. So I will help you with that one. Okay. So now write function, then in bracket. So the in bracket what will go? We will take the sequence. Okay. So you can type x. No. Just type this is a variable x underscore sec x-s-e-q comma. Then you say your number of kmers you want. ठीक है ना? So you type kmer. Okay. Now inside the bracket, come outside. Curly braces start. Okay, enter. The first thing what we are doing string split. So you can copy the string split file from top. Copy this four portion here. Copy. Then inside this paste. Now replace hello with x. Very good. Okay. Now go up again. Copy the next line. The div. So now you see that 9 we have to replace with kmr, correct? Because it is the specific kmr we want. Kmr. Very good. It's fine. This is fine. Everything is fine. Now go up again. Copy the next line. There's a whole line. Take the whole line from for loop. Yeah. Yes. Copy. Paste. Now here just type kmr9 is there. It's fine. Leave it. But for the kmr, for example, here we have to change the 8. For example, the I plus 8 is there. Right? So now we have to write the condition for this. So what we do in kmr9, you go over there in the line number C. After the C, press enter. Yeah, enter. So this is the limit. So kmr limit. Kmr underscore end. End is equal to. Okay, this is kmr minus 1. You understood? After the for loop, enter, return, in bracket kmr9, in bracket not equal. Yeah, kmr9. Okay. Now give a function name 151. Go to the top. Give a name. Get gamer. Get underscore gamer. Arrow mark. Very good. Now run this. Control enter. Very good. Now type there. Get gamer. Get gamer in bracket. Press tab. X underscore here. So in quotes. Now type ATGC. Okay. And then comma. One more variable is there. Then tab. Gamer. Suppose we want to do 2. Just type 2. Control enter. Suppose now we want to do gamer equal to 3. Just replace the 3. No. Yeah, 3. Control enter. It's working fine. Now gamer equal to 4. Control enter. Very good. So you see, now you can change your X sequence. Make it bigger, more bigger. ATGC and type blah blah blah, something else. Yeah. Anything. Yeah. Control enter. So you are getting the point. So now we have been writing like individually the codes again and again. When you convert into function, so you have to generalize. So you have to understand this thing. So there is something called we write programming for generalization, irrespective of the sequence length or irrespective of your KMR, you can now find out the outputs directly. So that's the benefit of having a function. Otherwise, you have to write again and again, copy paste again and again, you have to type. So if you go to the code, yeah. See what are the things we have changed. The variables which are varying. For example, KMR, it's a varying stuff. KMR and it is also varying. There are some constants are there which you are using in the code block. For example, for loop is constant. The diff we already computed. That is a variable because it might change, so accordingly the for loop will change. But the structures are almost same. So first is that you do string split. Then second you find using the length, you will find the how many loops you want. Then third you are creating an empty vector. And the fourth you are telling that what is the length that it has to capture. So for example, where you mentioned 1 is to I plus the length. So here it is a KMR minus 1. So it will give you the particular length. Okay, and everything is almost same. So now if you want to actually more make it readable, so you can actually just take KMR equal to C in respective of 8, in respect of 9. Go to there, 154 line number. Yeah, just do here KMR underscore output. Okay, now copy this one and change there in the here. Yeah. Okay, come down. And here yeah. Also one thing we can do, the diff whichever we are saying, there is no diff actually. There is number of loops. So remove that diff, say n underscore loop. Okay, now this you change here, 1 is to n underscore loop. So you see now it is more clearer. So whenever you are putting your variable name in context to your operation, you will remember the code effectively. Okay, for example, now you have a x, which is from the x set we are doing the split. So you can write there also like x underscore letter. You can just like a x underscore letter. Now you understand. Okay, this from the sequence we have converted to letters. Now you use this x letter there. Yes, change there. Very good. Done. Okay, and there in the KMR letter you have to come down in the for loop. X is there, x is there. Yes, there you have to change to x underscore letter. X underscore letter. Now run again, then check whether your everything is working. Very good. Now come down here again. Run this one. Perfect. Okay. So this is how we write. That's how we structure our code. Very, very important. So you have learned very important concept which is called string split. It is very, very important. You have to understand how to subset between the vector and between list. Then we have not moved into the data frame yet, but we have just given an input. Then you have also learned something very important, which is space, how to join information. Okay. So let's go for break for a lunch. Then we'll come back and we'll start statistics. Okay. So I hope you guys are very much familiar with this one and you will practice more to get this done. Okay, na? And why we are learning this one, Kemal? Kemal, we are learning because in alignment of your long sequences, short reads, you require to map your reference data with your observed reads. For that, you require mapping, and that is what in the backend it works. First, the small chunks are the kmers, the reads, because of defined in claim, and you are mapping back to your genome sequence or transcriptomic sequence. Okay. The code I will push it, don't worry about that, but most importantly, take a DNA string and convert into a RNA. Okay. Is it fine? Yes, sir. Perfect. So let's go and have food and come back. And we will start this 3 problem statement. Okay. And also the group is for a couple of more stuff. For example, if you are facing any problem in your PhD problem, you can just dump there the questions. I will get time and I will give you the help also there. What are the books you require to read? What are the resources that you require to read? Not only that one, you will get other stuff also. For example, for your PhD problem, what are the research articles that you should read? What are the review articles you should read? Okay, if you feel those things also, if you want, I can support you that. Apart from the programming aspect. Okay. Okay, chalo.